Hey everyone, this is Nico from the Decentraland Foundation, and in this video I want to show you a brief overview of what comes in the default code that ships whenever you create a brand new scene with the Decentraland editor using the inspector. Now, in the previous video I showed how you can use the drag and drop UI to position items and create static scenes, but the idea of this video is to dive into the code and show you how you can actually create interactive stuff that is a lot more fun and enjoyable to play. So one thing you might notice is that whenever you create a brand new scene, in the inspector view you see this magic cube which looks white on the scene, but when you open the same scene via the preview, you'll see that that same cube is blue and it spins. And that is, both of those things are achieved via code, and I'll show you how that is done. So you first have to navigate to the Explorer tab right here on the left panel of Visual Studio Code, and here you can see all of the files that make up the scene. And if you go to the src folder, that is where all of the TypeScript code is for this scene. This is all of the code that describes the interactive side of my scene. And we will go to the index.ts file. Notice that there are a few lines at the start that are just importing different things to this file. We don't need to look into these. These are auto-generated and not very interesting. Then there's a couple of systems being defined. We will look at this later. But what I want to focus on first is on the main function. So the main function is the first thing that gets called whenever your scene starts out. And this is the ideal place to put any code that involves the behaviors and things that you want to start from the very start of the scene, from the very first frame. So the first thing we want to do is fetch our magic cube. You'll notice that on the inspector, you can see that the cube is called Magic Cube. That is the name being given here on the UI. And we can fetch that name via the command engine.getEntity or null by name. And in this case, we are calling Magic Cube. And with this, we are fetching a reference to that very same entity that is here and that we can move and keeps being the same entity. So notice that the command's name is getEntity or null by name. And this or null is there in case, for example, I were to delete this entity or I were to rename it. Suddenly there will no longer be anything that I can fetch by the string magic cube. And that is also why I'm doing this little thing here, which is a good practice, to just add a little if, make sure that there actually is something named magic cube, because if there isn't, this will return null, and I know none of the things I want to do later will make any sense. So with this safeguard, we can dive into doing stuff to our entity that we just fetched. The first thing we'll do is the simplest. We will give this a material, and this is to color it blue. Now, if you're not yet familiar with SDK 7 code, you might notice something that might be a bit unusual or unexpected here. In SDK 6, we would be doing something like cube.addComponent, and we would do something like new material and then pass the properties of the material. Now on SDK 7 code, we are actually flipping things around, and we're not taking the entity as the access point and then adding components to it, but rather we are taking the entity, the component class, and then creating an instance of that component class and then referencing which entity we want that component to be assigned to, and then passing parameters. Now, this might be unfamiliar to you at first if you're used to SDK 6, but I assure you that it's no more complicated, and it is best practice in terms of how this then works with the performance of things internally. So like that is the reason why that has been refactored. So in this case, I am basically creating a new material component, assigning it to my cube, and this here solves the mystery of why our cube is blue. I could just as well make it red, and if I save, I will see that the cube is now red. Another component I am giving this entity is a custom component, and this component is named Spinner. This is not part of the default SDK. In fact, I am importing this Spinner component from a file that I created myself named components, or rather that is created with a template file as part of the template's contents. Now this spinner component is defined here. It's just a one-liner, and it's a very simple component. We can potentially have components that have like all sorts of complex data structures, but in this case we're calling a component named spinner, which is again named spinner internally without an uppercase. That's kind of irrelevant to you, but it's used internally. And it has the following data structure. It has a speed property, which happens to be a number, indicated by schema.number, just indicating the type of this information. So now, whenever I am creating a spinner component, I need to pass a speed property as a number, and that property is used to determine how fast the cube is spinning. So for example, if I were to change this 100 to 50 and save, you'll notice that it spins noticeably faster. And of course, this component that I've defined here isn't really doing the spinning, right? You've seen this here, and all the component really is doing is it's being defined as a type which has a specific informational structure internally. Now, the way that this becomes, the magic you're seeing in the scene, the way that this becomes actual movement of the cube is via a system. So this template also includes a system that takes care of that, and this is the circular system. You can see that this is being imported here from the systems file, which is also part of the SRC folder. And on this systems file, you will notice that there is a definition for the circular system. Systems are what give the scene action. They are the actuators that make things change over time, while entities and components are simply there to specify the state of things at one given point in time. The systems are the things that actually make those states progress and change over time. So right now my cube has a couple of components. It has, as we saw here, it has a material component that we just gave it. It has a custom spinner component, and it also had a couple of components that were given by the inspector, which are its transform and also its shape as a box shape. Now, the system that we are using here is gonna iterate over every single entity in the scene that has both these two kinds of components. So it's gonna fetch a list of all of the all of the entities that have both the spinner component and the transform component. In this case, we only have one such entity, which is the cube, but I'll show later that we could have multiple ones and the same would still apply to all of those. So once we have this list of entities with spinner, we can iterate over this list and go one by one over each one of these entities and do a little update on them. And in this case, we are fetching the transform of this entity. By the way, we're fetching a mutable version of the transform, and that is because we intend to change this transform. A reminder here, in SK7, one other interesting thing that has changed in SK6 is that we now have the concept of mutable and immutable properties. The idea being that often you only want to fetch a read-only version of the data in an entity, and that is sometimes way more performant than fetching an editable, a mutable version of that data. And if you were to always be fetching mutable versions of data, even when you're not intending to change things, that really has an impact in performance. So it's a good practice to fetch only the immutable version of entities when you only plan to read values, and then fetch the mutable version of these components when you only have the intention of changing these values. In this case, we do plan on changing these values. So we're fetching data from the transform in a mutable way, but we're also fetching data from the spinner in an immutable way. As you can see, we're using get here rather than get mutable. And the difference here is that the data we're fetching here for spinner cannot be edited, because I don't have any intention of changing the speed property of the spinner. I do have the intention of changing the rotation of my cube. So once I have references to these two data points, I can take the mutable transform and change the rotation to a new value. What I'm doing here is multiplying the current rotation by a little bit of math here that we don't need to get into, but basically I am taking the spinner data.speed as part of the factor, and with that I am able to make the speed at which it turns proportional to what is stored in the spinner component. Now, as I mentioned, we can also make other things spin. For example, I have this cart here. Let's check what I named it. It's cart big closed. So let's, for example, also do cart and fetch it via engine dot get entity or null by name, and let me refresh my memory. It was cart big closed. I can also rename these to nicer names if I prefer. So now, once again, it's a good practice to make sure that there actually is a cart with that name. And so I will enclose all of my code in this if cart. And now I can do spinner.create to create an instance of the spinner component, and I will assign it to the cart entity. Now the cart component is also expecting some data. In this case, I am expecting to see a speed value, which is a number that's, say, 15. And with this, I should also see that my cart is spinning as well, just as my cube. So great. The next thing I want to look at is this line here. I'm giving the cube a mesh collider component. Notice that when the cart is rotating in a certain direction, it is going outside the scene boundaries because it is a small one parcel scene, and you'll notice now that, just a second, that there is a red, never mind, there we go. Notice that there's a red square right around it when it peeps outside the bounds of the scene. Never mind that, that's not relevant here. So I was saying, the other interesting thing about this is that we are adding a mesh collider component to our box. And we could, for example, do without the collider. And what will happen then is you notice that I can walk right through it. Colliders are there to do two things. On one hand, they block my player from being able to walk through it. And on the other hand, they are there to make things clickable. If you see now that I added the collider back, if I were to jump on it, you can see that it now has volume and now stops my player from walking right through it. But the other interesting thing is that I can make it clickable, and that's what I'm doing with this final bit of code. I'm using a pointer event system, which is a helper in order to interact with entities in like a more organized way. So this onPointerDown function is going to expect two sets of data. One is a set of properties. Here we're specifying what entity we want to assign this to, and then we're passing an ops object which includes what button I want to use, in this case the pointer, meaning my mouse button, and what hover text I want to see when I am hovering over it. Maybe with the screen so narrow I'm not seeing it, but here is the hover text, which is probably a bit small for you to see on this recording, but it says the text spawn. Now the second thing that I need to pass to this function is a callback function. This callback function gets called every time that I click on the cube. And what this is doing is it's calling a function that I have defined somewhere else called createCube, and it's creating a cube in a random location. So if I press this, notice that every time I press it, a new cube is appearing. Maybe not seeing it every time because sometimes it appears off screen, but here they are, all a bunch of different colored cubes. And this is done by a function that you can find in this factory file. Here, createCube, and this function is basically creating an entity, giving it a series of components, including a transform, a box mesh render, a collider, a material, and a spinner, so that these also spin. You notice that they spin significantly slower, but they're also spinning at a also, by the way, at a random velocity. So the final thing that you'll also see here is that after I create a cube, I am also adding a bounce scaling component. And this is not very different from what we just did with our spinner component. There's also in this default project a custom bounce scaling component, and this component has a number assigned to it. That is the data that it holds. And there's also a system which refers to this component. So I won't go into detail to avoid making this video too long, but what this is doing is it is scaling up and down the entity so that it has this little bouncy cool effect. So notice it there. And interestingly enough, whenever the transition is over, we are removing the bounce and scaling component from the entity so that it finishes processing the entity. There could potentially be many entities that are running the bouncy scaly animation simultaneously, but in this case, it can only be assigned to this one cube right here. So I hope that was useful to you and that you can take this newfound knowledge into your scene creation process. And I can't wait to see what awesome things you build with these tools. Thanks for watching.